Okay, so after understand the difference between the concave corner and the convex corner. For convex corner, even you have a 1-1-1 surface to protect the convex corner, the corner still can be attacked, right? So we call this a corner attack problem. So for corner attack problem, you want to make a mesa structure. That means like a mountain structure above the surface. It's not easy because of the extrusion part always being taken away. Yeah, so for concave structure is also it's okay. For cavity, for hole, it's easy to fabricate for cavity, for trench. But for mesa, that means the extrusion, like mountain structures above the surface is not easy to form. So that's why people try to think of a way to do the, we call the corner compensation. Okay, for corner compensation, for example, yeah, so this is the real experimental results from the cantilever beam we just mentioned, okay? So after certain times of etching, you can see the convex corner, the material can be attacked. So some longer beam, you still can see some materials are left underneath, right? But for shorter beam, the underneath material has been taken away thoroughly. So until the final, 1-1-1 plan as the destiny to stop over there, the etching, stop over there. But still we have some remaining underneath. So if you put this structure into the etching solution for longer time, so all the materials underneath will be taken away for a longer beam, similar to the shorter beam. Yeah, in out, all the surface will stop at the 1-1-1 surface at the bottom here, okay? The black one over here. You see the black one. All the surface will stop over there, finally. So this will show you some intermediate results. Okay, it's not finally finished. So you want to make a mesa structure, for example, like this, mesa structure. However, because the corner will be attacked, as I mentioned. So the mesa, if you don't do any effort, okay, you never form this kind of beautiful structure. You always like this on the top here. So the corner will be attacked. You become more like a cone structure instead of a mesa. Okay, and this is not the final structure actually. If you leave time longer, you still will find out all the material will be taken out. You leave only a plate suspend above the surface. Okay, leave not any material underneath. No material underneath. Finally, okay, so it's not good. So that's why we need to consider the corner compensation problem. The idea for corner compensation is because the corner will be attacked, so you want to etching down to some kind of depth to leave this kind of extrusion structure, like mountain structure. So we need to consider maybe we need to extend the time until the corner be attacked. Okay. So for example, we extend the max material, okay, in the corner region to be longer. So we can etching down to the surface to form the mesa structure on the other side. But on the corner, because we still have some material, mass material over here, so he will not touch the corner until certain time. So you can design the length and the width, okay, to protect the corner according to the depth you want to etch down. Okay? So for example, you want to etch down 100 micron to have 100 micron mesa. So you need to consider how to protect this corner to be protected for 100 micron etching time. Okay, for example, if 100 direction here, so we have for example 100 direction here as well, etching from as well. So we need to have the width, okay, half of the width, the same as the depth you want to go. You want 100 micron final depth of the etching, you will end up design like 200 micron of the width of the corner compensation structure. This is fundamental idea. But corner compensation structure is not easy to design, actually. According to different etching, they have different behavior. Okay, so now we go back to the one we just omit. The etching different agent, the agent property, but from different agent. So come back to this one. Okay, so here shows you several common agents we use for augmented machining. Okay, so those agents are different from the HNA. HNA has a very strong oxidation ability. So no matter what kind of material you put down, you always agent isotropically. Okay, but only for some special agent, the agent ability is not that strong. So they will select different crystal orientation for different agent rate. Okay, for example, like KOH, the most useful and the most common one. The KOH actually can agent down the silicon with different agent speed. So you can compare three different phases, 100, 110, and 111. You can find out on 111 plane, the agent rate is quite slow. Okay, 0.5 micron per hour, quite slow. So if we don't consider it so seriously, we can omit it. Yeah, we don't consider it. Sometimes we consider it 0. But in the homework, we'll give a very hard homework. If we really do consider this agent rate, what kind of final structure we'll get will be different from the one, the ideal one I just showed you. Give you some challenge to think of. Okay, but in your homework, don't worry. Okay, so you have 2 more weeks to work on that. Okay, so but just remember, we have a 1-1 surface always give you the slowest agent speed. For 100 or 110, the speed is higher, but depends on crystal orientation. They still have some agent speed difference. Okay, so in KOH agent, the second slowest surface will be 100 surface. The fastest one will be 110 surface. Okay. So because of this property, that makes the corner compensation even harder because you need to consider crystal orientation again. Okay. So we will discuss about this later. And another type of agent we call the EDP. EDP is acid endowment pentachemical. It's a very special chemical. This chemical smells quite good, actually, but it's quite harmful for your health. Yeah, it's a cancer-causing material, so don't breathe too much. Yeah, I used it a lot actually during my PhD study, but I never use that anymore when I come back to Taiwan. So don't worry about that. So in your lab, we don't have these kind of things anymore. For EDP, there is organic type agent, very different from the KOH. It's potassium hydrothiol. So it's different from KOH is organic type things. So it's quite good if you want to have the material compatible with the IC process. I think is okay. But the question is very harmful, so that's why people don't use that anymore. For EDP agent, actually, the agent speed is 100 speed is higher than 110. Actually, there are 3 different types. Here I show you only the type S. There are 2 more different types. You can see the agent speed is this one is higher than the other one. Okay. So remember, the agent speed for EDP for 110 and 110 wafer is opposite to KOH agent, because we will discuss about the corner compensation the design. Because we will design 2 totally different types of corner compensation for these 2 agents. Okay. The other 3 agents, for example, like the hydrozyme, is a rocket fuel material. Okay, it's also harmful for your health. So people are not using this anymore. And the other one is ammonia. Ammonia is also okay to agent, but you can see the ratio between 2 phase, 111 phase and 100 phase. The ratio is not high enough to give a very good contrast. Give a good contrast, the final result structure will become very beautiful, similar to your ideal sample. However, if you have this kind of only 10:1 ratio, you got a very strange structure end out. And also, the 1-1 surface cannot stop the agent good enough to protect your front, agent front. Okay, so it's still not good.